My name's Dr. Elaine Clapman-Green, and I'm just quickly going to talk you through the effect of UVC decontamination on FFP3 mask fit and microbial load, which is a project we've recently been undertaken at Great Ormond Street Hospital. This project was undertaken by a multidisciplinary team, including infection control professionals, healthcare scientists, and decontamination professionals. The first thing to really understand is the clinical problem. SARS-CoV-2 has caused a global pandemic, which is mainly spread by droplet transmission. In response to that, the use of masks is now widely recommended both within healthcare and in the community setting. Within England, FFP3 masks or FFP2 masks can be used for the protection of staff when they're undertaking aerosol generating procedures. This project mostly focused on FFP3 masks, which are the mask of choice for staff undertaking this kind of work. However, they are in limited supply. As you can see in the poster that is provided to staff within Great Ormond Street, you can see there are a number of different FFP3 masks available. These are very different shape and fit, and this is because not one mask tends to fit all different staff. And the supply that is available to us does vary from week to week, depending on national stocking. The suggestion, therefore, has been that we could decontaminate masks in between use using UVC light in order to make one mask last longer. Manufacturers do recommend that masks can be used for up to 8 hours. At GOSH, we use FFP3 masks for sessional use. This means they can be used for up to 2 hours and are then disposed of. The additional being able to use this for a repeat session would therefore help deal with some of the challenges that are caused by limited supply. And a recent review did state that a single cycle of UVC should not impact on fit and therefore mask use. However, a single decontamination cycle is unlikely to sufficiently help us impact the problem. This study involved the use of a UVC cabinet to examine how we could decontaminate masks. Initially, the work involved inoculating both Staph aureus and E. coli onto uncomplicated mask surfaces, so just fluid repellent surgical masks that are widely used for non-aerosol generating procedures. The advantages of this is that they were a flat surface, and we know that UVC has issues with shadowing affecting its ability to decontaminate. Then, once this work had been done, we inoculated the same level of E. coli onto complicated masks such as FFP3 masks themselves, but using 4 different shaped varieties to see whether we got the same level of load reduction in more complex surfaces. The other piece of work was that 4 members of staff wore their masks for the 2-hour sessional use, had a UVC decontamination cycle, and then were fit tested to see if the mask would then pass fit testing again. This was repeated until failure. So the results of this work showed that you could get a greater than 10 to the 6 load reduction for both E. coli and Staph aureus on uncomplicated surface samples, where the UVC was able to affect all of the surface. 6% of the complicated surface samples, however, did fail to reach this 10 to the 6 load reduction, and that's probably due to the complex shape of the masks themselves. But the most important thing is, of the 4 participants who undertook the wear, decontaminate and fit cycle, 1 failed after 4 cycles, 1 failed after 3 cycles, and 2 members of staff failed after 2 cycles alone, which means that masks would at most be suitable to be worn for an entire day. This means that although UVC can decontaminate, especially uncomplicated surfaces, it's unlikely to be the solution to FFP mask wearing where stock is limited.